in autonomous vehicle programming for university students. The authors are 2024 Bill Frank Huang, Fentai Zhang, Dan Jin, Tony Peng, Wei Tang Ming, and Fang Chuan Huang from FPT University of Vienna. Okay, let's welcome.
Okay. Hello everyone, my name is Yet and I'm here to present about our project design an AUTOCAR kit based on project-based learning for university students. Our team include Bùi Phi Hùng, Phạm Thị Trinh, Nguyễn Quang Hiệp, Vũ Tuấn Linh, Khuất Đức Anh, and Phan Duy Hùng, and we are from FPT University, Hà Nội, Việt. My presentation will cover 9 sessions. I will start with the introduction and literature review, followed by the hardware and software. Next, I will explore the project-based learning with the user manual. Then finally, I conclude with a future goal and a demo. For the first, for the introduction, we outline 3 criteria for our kit. For the hardware, it must be a modern car kit, easy to assemble, and with a reasonable price. For software, it's a open source code for self-driving car kit with the AI lab, and for the documentation, it has to available in both English and Vietnamese. Therefore, the AI, our kit will have 3 main AI functions, like following, identifying and tracking the car traffic signal and responding accordingly. Move on to the literature review. Today on the market, there are a lot of AI kits. For example, the first is Desk Racer AI kit from NVIDIA. This robot used in professional AI racing car competition with a price of about $500. The second is AI machine learning starter kit. It's the kit for the student to get hands-on the AI education and with the price about 270. And the last one, which is familiar with our kit, is Indigo. This is a kit for beginners with 3 years old, and this kit does not include the AI knowledge with the price of about 76. Most universities provide the AI knowledge is about machine learning, deep learning, and image processing. However, there are no tools to support them to apply the knowledge to the real world challenge. Additionally, our research shows that there are trends in applied robotics on the AI education. However, they have a lot of limitation on efficacy and applicability. Apply. That's why we aim to create a kit with a reasonable price, with the AI lab, and have ability for writing in the group. Next is the hardware. The kit will connect and communicate with 3 computers via a gateway using UDP. The kit will capture and send the image to the main computer. Then the main computer process the image to lab redaction and streaming them to the other subcomputer. They will have the car to identify the traffic signal and the vehicles, then send back the control command to the main computer and back to the kit to control the motors. This is the structure of the kit, and this is the whole component of the kit with the main USB 32 model and the map user manual. For the map, we split the map to many small pieces with the material of formats. These are all the parameters of map and signals. All the dimensions are computed based on the real material. The advantage of the map is very compact, flexible, and easy to assemble to create diverse layout. For the program on A332, there are two tasks run in the parallel on the free TOS environment is to get the image from camera send and receive the command and controller model. For the leader's computer, there are four tasks run in parallel: receive the image and stream, processing image for land following, receive command from another computers. On the member's computer, that they will receive the image from the main computer and detect the vehicle to the side and send back the control command. That is the most important part. It's about project-based learning. Teacher will provide the student a project. Through that, student can learn how to apply the AI knowledge to a real-world challenge and how to manage project, work as a team. This method will have is with efficacy in both teaching and learning. And some research show that this method will have the student gain a deeper understanding of theory and gain a lot of motivation. Therefore, we create the user manual will include 5 sections. For the guide with the software, we describe the function of the kit and how we start and interact with the car. For software, we suggest some IDEs communicate with the vehicle, how to set up and install the library and communicate between machines. After complete that chapter, we receive a card with, with a sign of 13 is 16 and the address around 13 to 15. Go to the chapter 1 in lab detection. The theory is about the OpenCV library and Kenny algorithm. We split the whole lab of the chapter to 3 small, small lab with the increase of difficulty. Therefore, the first lab is about how to familiar with OpenCV line, and the second is about Kenny, and the last one is apply the Kenny to line flowing vehicles. In the last lab, the student have to play with 3 word challenge. Is about handle cam perspective calculation, how to adjust the candidate and improve performance with perspective transform. To chapter 2, the theory about data pre-processing with yellow feedback, and the lab is about how to prepare data set, how to train the model yellow feedback basic, and configure the parameter for better performance. The chapter 3 is about object tracking with the theory of deep shot, a popular theory with a popular algorithm used with Willow for tracking tasks. The last one is about basic knowledge about deep shot, and the last 2 labs is about applying yellow Wi-Fi with deep shot to tracking traffic signal and tracking car. Upon completion, we create a comparison table to highlight our advantage. First, as you can see, our kit don't have the small AI computer on the car. It helps us to reduce significantly the cost. Secondly, our kit have ability for applying with AI education and for group projects. And the last one about the cost, we estimated the cost is just around $50. On the conclusion, our kit will achieve 3 outstanding. First is your practice case at a reasonable price. The second is about the document is built according to the project-based learning method. And the last one is provide the ability to practice in the groups. On the future work, we aim to reduce the size count. Therefore, we can protect this component better and reduce the size of the map. We went with the demo to optimize the performance. We create the map demo as follows, and this map has ability to test all the lab in the document. And this is the demo. As you can see, the car is controlled by 3 computers. The first in the left is the lead computer for line flowing. The second in the middle for tracking car signal, tracking traffic signal, and the last one on the right for tracking car. That's all I want to share about our project. Thanks for listening.
Okay, thanks, presenters. Any questions? Okay, I have a question. Yeah, so what is the performance of the object tracking by using Unify?
Um, so the performance is about 80 to 85%.
Yeah, 85%.
Yes.
The accuracy?
Yeah, just accuracy 80 to 85%. With the FPS is about 70
Okay.
on the third laptop.
Okay. Okay, thank you. That's right. Thank the presenters again.